In this video, we are going to learn how to name alkynes. In order to name alkynes, we need to find the longest chain of carbon atoms that contains the carbon-carbon triple bond. Now, the alkane name, we're going to replace that ending of "ane" with "ine" because we are naming an alkyne. We're going to number the carbon atoms starting from the end that is nearest the triple bond. Similar to specifically alkenes, sometimes we can have triple bonds that are specifically equidistant. So always watch out for that. And only then the correct numbering is beginning to the end that is the closest to the substituent, the first substituent that you have in the molecule. Next, you are going to give the location and the name of the substituent as a prefix of the main chain. And you need to give the location of the first carbon in the carbon-carbon triple bond. Understand that the whole idea of cis and trans isomers does not exist in alkynes. It's only a feature of alkenes. Let's do the following examples that we have on the slides. In the first example, take a moment, find the longest continuous chain of carbon atoms that include the carbon-carbon triple bond. In this structure, the longest carbon chain is 1, 2, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, 6, 7. Regardless, you have the same longest continuous chain of carbon atoms containing the triple bond, which is 7 carbons. So let me select my parent chain. You could have selected the other one. I decided to select this. We have 1, 2, 3, 4, 5, 6, 7. So since this is an alkyne, if I have 7 carbons, that is called heptane in an alkane name. But because this is an alkyne, that's heptyne. I have to give the location of the first carbon in the triple bond, which is going to be carbon number 3. Next, I'm going to write the substituents. In this case, I only have 1. And you can see that specifically on carbon number 6, I have a methyl group. That's going to be the prefix of the parent chain, the main chain. So the name of this structure is 6-methyl 3-heptyne. Next, I have a skeletal structure. And I want you guys to practice looking at skeletal structures for alkynes carefully. I'm going to write the correct longest carbon chain for this molecule. When we have an alkyne, because alkynes are technically linear, the number of carbons that we have in our parent chain is 1, 2, 3, 4, 5, 6, 7, 8, 9. I started from right to left because that's the end that is closest to the triple bond, which it is my priority. Understand that the substituent is not the priority unless your alkyne is equidistant. So a 9-carbon alkyne, I can write no name for the 9 carbons, but because this is an alkyne, I erase the ane ending. and I write no 9 because it is an alkyne. Carbon number 1 is the first carbon in the triple bond. On carbon number 5, I have a substituent. Let me highlight my parent chain. Carbon number 1, number 2, number 3, 4, 5, 6, 7, 8, 9. So on carbon number 5, I have a substituent. Since it has 1, 2, 3 carbon atoms. At carbon number 5, that's called the propyl group. So the name of this alkyne is 5-propyl 1-no-9. Make sure that you practice from the worksheet that has been provided for this concept. Let's do one practice together. Take a moment and name the following alkyne. This is an equidistant alkyne. Let me illustrate why. If I go 1, 2, 3, 4, 5, 6, 7, 8 versus 1, 2, 3, 4, 5, 6, 7, 8 in any of the two directions, my carbon-carbon triple bond is between carbons 4 and 5. Now, there's only one correct numbering of the two. The correct numbering is the green one, because since this is an equidistant alkyne, then I'm going to number the alkyne from the end that it is closest to the first substituent. Taking that into consideration, the name of this molecule is going to be 4-octine for my parent chain, and then 3-bromo. So the name of this molecule is 3-bromo 4-octine. Make sure that you practice, because all of these concepts take lots of practice. Make sure that you're also familiar how to draw, specifically if you're given a name, the condensed and skeletal structural formula for alkynes. So I'm going to do the first one as an example. I have 4-methyl-1-pentyne. To draw the condensed, remember that I'm writing all of the atoms. So pentyne refers to a 5-carbon, 1, 2, 3, 4, 5-carbon alkyne. The number 1 before the pentyne means that there is a triple bond between carbons 1 and 2. On carbon number 4, I have a substituent, which is a methyl group. Because of space, I'm going to make it point down, but you can make it point up. And then I'm going to fill in the hydrogens. The first carbon gets 1. Second carbon gets none. Third carbon gets 2. Fourth carbon gets 1. Last carbon gets 3. Remember that the reason why I'm assigning these hydrogens is to complete the octet for this compound. And since these are hydrocarbons, when we are filling in the atoms, it must be hydrogens because I already wrote in my carbons. Now, when it comes to the skeletal structure for this molecule, understand that triple bonds are linear. So that carbon-carbon triple bond that you see between carbons 1 and 2 is a linear molecule. So once I draw those three lines, that is representing carbon number 1, carbon number 2. And if we follow the geometry of the rest of the carbons, this is tetrahedral. The two hydrogens, the two bonds, that makes 4 electron groups. This carbon is tetrahedral, this is tetrahedral, this is tetrahedral. So for this molecule, since this is carbons 1 and 2, I need to write in carbons 3, 4, and 5. And what I do is that after I write that my triple bond, I go, this is carbon number 3, carbon number 4, carbon number 5. And then for this molecule specifically, on carbon number 4, we have a methyl group. So I just draw a line, and that's my methyl group. So that is the correct skeletal structural formula for 4-methyl 1-pentyne. To conclude the family of hydrocarbons, let's understand that molecules that have a benzene ring are known as aromatic compounds. So an aromatic compound is not a compound that has aroma. It's a molecule that has a benzene ring in its structure. Benzene rings can be drawn by looking at a hexagon with alternating double bonds and triple bonds. But because essentially there are two ways that you can draw them, instead of drawing the lines, you may choose to put a hexagon with a circle in the middle. That also represents a benzene ring. So just keep that in mind if you see it in assignments or in further chapters. There are specific aromatic compounds, meaning molecules that have benzene, that have a common name that it is utilized often to identify them. So if I have a benzene ring with a CH3, that could be named as methylbenzene, but that is also known as toluene. If I have a benzene ring connected to NH2, NH2 is an amino group, and since connected to benzene, that's why the name of the structure, you could name it as aminobenzene, but then the common name is aniline. Lastly, if you have a benzene ring connected to an H group, that is known as hydroxybenzene, because an OH group is a hydroxy group. But this functional group can also be known as phenol. For naming these molecules, the only ones that you're responsible for knowing structure and name are toluene, aniline, and phenol.